Welcome to Study Loop.
Hello friends, here it is given. An ideal gas refrigeration cycle with two stages of compression with intercooling using air as working fluid. We have to calculate coefficient of performance of the system and mass flow rate. Properties of air to be used: specific heat of air to be 1.005 kilojoule per kg per Kelvin and adiabatic constant to be 1.4. Using temperature pressure relation for adiabatic process, we can write temperature of second state to be T1 into P2 upon P1, that is compression ratio of pressure whole to the power K minus 1 upon K. Temperature of first state is given in the problem 249 Kelvin. Compression ratio is given in the problem 3, that is 1.4 minus 0.4. So temperature at second state you will get 340.8 Kelvin. Now temperature of fourth state can be obtained. T4 to be T3 P4 upon P3 whole to the power K minus 1 upon K. Substitute the value. Temperature of third state is given 278, that is given in the problem. Compression ratio of pressure is 3, that is 0.4 upon 1.4. So we will get 380.5 Kelvin. At state 6, temperature can be defined as temperature of fifth state into P6 upon P5 whole to the power K minus 1 upon K. Temperature of fifth state is 278. Compression ratio of pressure is 1 by 9, which is given in the problem. 1.4 minus 1 upon 1.4. So you will get 148.4 Kelvin. Coefficient of performance of refrigeration. You can define amount of the heat transferred at low temperature upon total work done. Total work done is defined as work in by compression minus work out by turbine. Amount of the heat absorbed at low temperature can be defined as enthalpy of the fluid in state 1 minus in state 6. Work, work done in by compressor to be H2 minus H1 for first compression, and for second compression it is H4 minus H3 minus work output by turbine, so H5 minus H6. All these can be converted in terms of temperature. So coefficient of performance of refrigeration, we will write T1 minus T6 divided by T2 minus T1, T4 minus T3 minus T5 minus T6. Putting the value, temperature of first state is 249, temperature of sixth state is 148.6, sorry, 148.4, T2 340.8, temperature T1 is given 249, temperature of fourth state is 380.5 minus temperature of third state 278 minus temperature of fifth state 278, and temperature of sixth state is 148.4. So on solving it, coefficient of performance you will get 1.56. So this is one of the answer. Now we have to find mass flow rate, which can be defined as a rate of refrigeration, can be defined as mass flow rate into specific heat at constant pressure upon change in temperature from first to 6 T1 minus T6. So mass flow rate you will get rate of refrigeration divided by specific heat into T1 minus T6. Substitute the value. Refrigeration, rate of refrigeration can be written as, it is given in the problem, 45,000 upon 3600 kilojoule per second upon specific heat is 1.005, temperature of the first state is 249 and sixth state 148.4. So you will get mass flow rate to be 0.124 kg per second. That's all. Thanks for watching it.